Now we'll hear from our musicians, and Patrick will introduce Dr. Yoni Khan.
Thanks so much, Lindsay, for that great session. So Professor Yoni Khan is an assistant professor of physics at University of Illinois Urbana-Champaign, whose research focuses on detecting dark matter. Now, he holds a bachelor's in physics, as well as mathematics, as well as a bachelor's in music and horn performance, and a certificate in music composition from Northwestern University. So he's really super well-rounded and a perfect panelist for today's session. So he received his PhD from MIT in 2015, during which time he fell in love with the historical instruments and co-founded the Period Wind Ensemble and Orchestra Grand Harmony. Now, as a musician, he has performed with leading Baroque and classical ensembles across the US and is a member of the orchestra for the period opera company Teatro Nuovo. You can correct my pronunciation on that. Yoni, take it away.
Thanks so much. So you'll excuse my voice. I'm glad I'm not singing today, just playing. My son caught a cold in his first week of daycare, and so this is, I guess, what we're gonna have to deal with once we're getting out of quarantine. So thanks so much for the wonderful introduction. So I just wanted to start by telling you a little bit about myself and how music and particle physics have kind of intersected and interweaved themselves in my life throughout the last couple decades. So I've been playing the French horn since I was in about 6th grade, and I knew I wanted to do physics from the time that I was in high school. And I always thought that these would be kind of parallel things for me, that music was one aspect of my life and science was another aspect. They use the same parts of my brain, but in slightly different ways. I would always kind of find that when I would go into the practice room, when I was, preparing for a concert and I had some physics problem on my mind that was kind of bothering me, maybe 5 minutes in, that would fade away and then I would be completely focused on the performance. And then when I was done, I could come back to the physics problem kind of with a fresh perspective. And I found that always pretty useful. But then I kind of found that, especially in my music writing, which I pursued kind of most actively when I was in undergrad, the way that I approached composing music, I think, was very similar to the way that I think about physics, and especially particle physics and fundamental physics, which involves things like principles of symmetry and elegance and putting smaller pieces together in a larger whole. And so I want to start by just giving you a couple examples of that. So I'm going to play a bit of a piece that I wrote back, I think, in 2006 for horn and piano. I am a horn player. I'm a very amateur pianist, and I definitely can't play both parts at once. This will be a recording of a previous performance that I did of that, but I'll play you some demos and talk through a little bit how I thought about writing this piece and kind of where the connections to particle physics are. So let me go ahead and share that recording. Okay, so I've always felt that music should be understandable and appreciable on its own with no background knowledge. You don't need a PhD in music theory or anything like that to understand what you're listening to. But I've also really enjoyed there being more under the surface the deeper you look. And now I kind of want to go through some interesting details of that piece and tell you about how it got constructed. So the very first thing, so I'll now give you the demo on the live instrument. The very first thing you heard was so those notes right there are part of what's known as a diminished scale. So if you play, it's an alternating sequence of half steps and whole steps. That kind of sounds maybe vaguely Middle Eastern, but it's not really part of the way that we usually think of major and minor scales that you might learn in the first time you learn an instrument. But this scale is so full of really interesting bits and pieces that fit together in a really fun way that it kind of underpins the entire piece. So in addition to that first horn theme, the thing you hear in the piano is actually that same series of notes just transposed a little bit. So comes from missed one note in there, but anyway, so you get the idea. So it's kind of this sequence of building blocks that kind of get put together, and then later on when the horn comes back, is exactly that same without that last note. And then when the piano continues and you hear this kind of interesting chord that closes the section that I just played, it's a combination of a major chord and another chord that kind of sounds nice on its own. When you put it together, it sounds kind of dissonant, but it's actually built up of exactly the same, those exact same building blocks that went into the original theme. So yeah, and so let me maybe play you another bit of this piece and kind of talk through some other things that happen a little bit later on. Let's see. Okay, so a thing happened there that I think is very cool, and so I want to explain to you a little bit of the thought process that went into it. So you kind of heard near the end of that segment this thing on the piano that sounded a little bit like. So the meter, which is set by the horn theme, is like 1, 2, 3, 1, 2, 3. So these are subdivisions into 3 parts. So 1, 2, 3, 1, 2, 3, 1, 2, 3. But each measure, so each bar of music, has 3 main beats where the horn is playing. But then right at the end there, the 3 inside of one beat turns into a 3 plus 3 plus 2. This is kind of syncopated rhythm that actually leads to the entire next section being much faster. So this is what's known in music as a metric modulation. And the idea is there's some sort of pivot section of rhythm that if you listen to it one way, it belongs to one kind of meter. And if you listen to it another way, it belongs to another kind of meter. And, you know, if I can make a little bit of an analogy to the way that I think about particle physics, there are building blocks of symmetry that make up the universe. And, you know, one example of that is the fact that the proton and the electron have exactly the same but opposite electric charges. It's not like the proton has 1.0001 times the charge of the electron. They're exactly equal. And if they weren't, our universe would look very different, and life, as we know it, probably couldn't exist. So in exactly that way that all the pieces of the standard model that Lindsay mentioned have to fit together in these exact kind of integer ratios, but they manifest themselves in very different ways depending on the phenomenon that you're looking at. This kind of idea of metric modulation is it can be a very mathematical way of looking at music, but I think that actually the effect, even if you didn't know what was going on, I think the effect can be quite beautiful. And so the way that I tend to think about writing music is the deeper you look, the more patterns you can uncover, and there's patterns on top of patterns, and at every level, your understanding of the piece can lead to enjoyment. You know, if you didn't hear me talk about any of this, you might enjoy the piece as it sounded. Now that you hear that it's built out of these thematic cells, maybe you'll enjoy listening for those more. They come back in lots of different ways than when I play the entire piece. And in just the same way, you know, we can look outside at a flower or the sunset and be awed by the beauty of nature. We can know that the reason the sunset is red is that light is kind of refracting off particles in the atmosphere, and we get the red light, and that's another layer of beauty. And then you can think about the cross-section for photons scattering off of individual atoms and why that leads to those scatterings, and you can understand even more beauty that way. But it's sort of, you know, there's beautiful structure all the way down. And so at any level, knowing anything about physics can, I think, enhance your enjoyment of the world. And the more that I thought about it kind of in preparing this presentation, I realized that that is a lot of the way that I think about music. Okay, so now I want to shift gears a little bit and talk about how I got into historical instruments. So I did my PhD at MIT in Boston, which is a really amazing city where you can basically throw a rock, and in non-pandemic times, you can hit 3 early music concerts. You might hear, you know, medieval recorders in one concert hall, and then some other orchestra on original instruments playing a Beethoven symphony in another concert hall. It's just a city that's full of music. And I had never really thought much about historical instruments until I got there, but I kind of wanted to do something new after doing this kind of standard conservatory program in my undergrad. And so I kind of fell into the natural horn, which I want to demonstrate for you now. So this is also a French horn, but it is the kind of the ancestor of the modern French horn. And you can see that it comes in 2 pieces. So this is called the body, and this is called a crook. So if I put this piece in, I can play certain notes. And actually the way this instrument was used once upon a time was actually as a hunting horn. You would play certain calls like, you know, kind of bugle call things that would say, you know, maybe you found a fox and you wanted your hunting party to come and grab it before it ran away, things like that. So the major innovation was to realize that if you put your hand inside the bell, not only does the sound change, but you can play more notes. So before, I could only play, and some of those notes sound a little bit less in tune than others. But if I put my hand in the bell, and I'm going to give you now the bell's eye view of what's going on. I can actually play a full chromatic scale. And you might also notice if you have perfect pitch, I apologize, but the pitch of this instrument is lower than the piano. So the scale that I just played, so the actual pitch of this instrument is a little bit lower because that's how they used to play back in the day. But the fact that you're kind of using the basic physics of the instrument, there's only so many notes that you can get, but then modifying it in this really interesting and quite literally nonlinear way to get lots of different notes led to another kind of beauty in writing for the horn, where composers tried to take advantage of the fact that the sound changed a lot when you have to move your hand to get a note that wasn't part of the natural instrument. And sort of, you know, to again make an analogy with physics, this instrument is sort of sound in its rawest form, but we can harness the basic laws of, you know, physics, in this case applied to sound, to do the things that we want. But there are things about the underlying physics that always manifest themselves. And in this case, it's the fact that the horn sounds different when you put your hand in the bell to change the notes. So if I want to play in a different key, I have to put in a different tube. So this tube will let me play in the key of C. And so if I play the same kinds of things, so now we're in a different key entirely. And so I just want to close, let me just make sure that I said everything that I planned on saying. Yeah, so this instrument, this natural horn, is actually now my main instrument. I find that the kind of thinking required to play this instrument is different and more engaging to me than I think on the modern instrument, because you really have to imagine each note before you play it, because there's no vowels. You know, this instrument is not helping you so much. You kind of have to tell it what to do, but also not try to force things too much, or else it'll kind of, you know, backfire on you. And so what I want to end with is just a little piece, which is an unmeasured prelude by a composer who was also a professor in the Paris Conservatory in the 19th century. And so these are kind of meant to sound like improvisations, the kind of stuff that a horn soloist might play before starting a concert to kind of warm the audience up. But it kind of plays with those same notes that I would only be allowed to play if I didn't use my hand, but then kind of fills in the notes around them in the context of, you know, the classical music scales that we're more used to hearing. And I should also just mention, this is the first time that I've played for anybody since the pandemic started. So thanks all for giving me the opportunity to do this, and hope you enjoy. Okay, so I'm happy to take any questions on the instruments, that kind of stuff, during the Q&A.